Morning. So in the last classes already we are discussing about the revision of Unit 5. That is already we discussed about the Laplace transforms, its properties, and some problems related to Laplace transforms. Right? Now we are going to discuss about the jet transform. Okay, jet transform. How it is defined mathematically. That is jet transform. The arbitrary function x of n can be defined as x of z. That is jet transform x of n is equal to sigma n is minus infinity infinity x of n into z power minus n. This is equation number one. Or we can say that the z transform of x of n equal to x of z. So this is varying from minus infinity to infinity. That's why it is called two-sided or bilateral z transform of the sequence x of n. Suppose if we take unilateral, then we can define this as minus infinity to 0 x of n into z power minus n, or n equal to 0 to infinity x of n into z power minus n. That is called unilateral z transform. So it is shown like this. So x of t is the input signal, this is multiplier. So this is a train of impulses. Sigma n is varying from minus infinity to infinity delta of t minus n ds. Okay. So by multiplying these two, we will get the discrete time signal excess of t, right? So this is the diagrammatical representation of the jet transform. Okay, right? Next, we'll take the individual diagram. This is x of t. It will be multiplied by train of impulses delta of t sigma n equal minus infinity infinity delta of t minus n ts. Okay, so by multiplying these two, we will get the x of n t as like this. So the range of values of z for which x of z expressed by equation 1, that is sigma n equal minus infinity infinity x of n z power minus n approaches to a finite value is called region of convergence. Okay. So how to get x of n by taking inverse z transform of x of z. So z inverse is nothing but the inverse z transform. Okay. And by taking the relation between z transform and Fourier transform. So here z transform is defined like this: sigma n equal minus infinity infinity x of n into z power minus n, where z is complex variable. It is represented as r into e power j omega, where r is the radius. Uh, it is nothing but a polar form. So that is z equal to r into e power j omega. If radius is 1, if r is 1, then z will become e power j omega. So r into e power j omega r x. If r is 1, then e x of e power j omega equals sigma n equal to minus infinity infinity x of n into r is 1 e power j omega. So how this Fourier transform z transform is related? So z transform r into e power j omega n, or z transform at z equal to e power j omega n is equal to Fourier transform of x of n, where r is unity, that is r equal to 1. So z transform reduces to Fourier transform along the unity circling complex jet plane as shown as this is the jet plane. See this diagram. This is the jet plane. So this is imaginary axis and this is real axis. So this is the radius 1. So with the z equal to e power j omega. So this is the omega, angle omega. So this is the unit circle with radius equal to 1. Right? So the ROC of jet transform includes unity circle, and the sequence x of n is also Fourier transformable. That is, ROC of right-sided sequence always lies outside the circle of finite radius r degrees. Okay. If the ROC of x of n includes unity circle, then x of n is also Fourier transformable. Okay. Next, we'll do the problems related to jet transform. Find the jet transform of the finite duration sequences given below. Here, two sequences are given, and also arrow mark is given at the middle of the sequence. So at 5, arrow mark is given. It means that its value is x of 0. X of 0 is 5. X of minus 1 is 4. X of minus 2 is 3. Similarly, this is x of 1 is 8. X of 2 is 9. Right? Similarly, for the second problem also, here x of 0 is 3.5. X of minus 1 is 1. X of minus 2 is 8. X of minus 3 is 2. Here x of 1 is x of 1 is 8 and x of 2 is 3. Right? So these are the two sequences given. So these are the two sequences given. How to find the jet transform for this finite sequence? As we already know the definition for jet transform, that is jet transform of x of n equal to sigma n equal to minus infinity to infinity x of n into z power minus n, right? So x of n is this one. Okay, so x of minus 2 value is 3, x of minus 1 value is 4, x of 0 value is 5, x of 1 is 8, x of 2 is 9. So x of z equal to sigma n equal to here minus 2 to plus 2 x of n into z power x of minus 2 x of minus 2 value x of minus 2 into z power plus 2. So x of minus 1 into z power 1 plus x of 0 into z power 0 plus x of 1 into z power minus 1 plus x of 2 into z power minus 2, right? So what is x of minus 2 value? That is 3. 3 into z power 2 plus 4 into z power 1 plus 5 into z power 0, that is 1 plus 8 into z power minus 1 plus 9 into z power minus 2. This is the solution for this problem. In the same manner, we can find out the z transform for the next series, that is 2, 8, 1, 3.563. Okay, here x of minus 3 value is 2, x of minus 2 value is 8, x of minus 1 value is 8, x of 0 value is 3.5, x of 1 value is 6, x of 2 value is 3. So here it is varying from minus 3 to 2. So x of n into z power minus n. So x of minus 3 into z power 3 plus x of minus 2 into z power 2 plus x of minus 1 into z power 1 plus x of 0 into z power 0 plus x of 1 into z power minus 1 plus x of 2 into z power minus 2. So x power minus 3 value is okay. So the ROC of the above signal is entire z plane except at z equal to 0 and z equal to infinity. So these two are finite sequence, finite time sequences. So similarly, we can find out the get transform for these sequences x of n equal 1, 2, 3, 4, 5, 6. So arrow mark is given at x, x of n equal 1. That means that x of 0 is 1, x of 1 is 2, x of 2 is 3, x of 3 is 4, x of 4 is 5, and x of 5 is 6. Similarly, in the same manner, we can do the problem for this second bit also. And then find the z transform sketch ROC for the discrete time sequence x of n equal to u of n. So u of n is its range is from u of n equal to 1 or n is greater than or equal to 0, as we already know that. That means that sigma n equal to 0 to infinity, u of n value is 1. Okay, so it can be expressed as x of z equal to z transform of x of n, that is sigma n equal minus infinity infinity x of n into z power minus n. So u of n value is 1 from 0 to infinity, right? So n 0 to infinity u of n 1 into z power minus n. So z power minus n whole power n alpha power n is in the form of alpha power n. So it is a geometric series 1 plus alpha square with the common ratio alpha by 1. Okay, second term by first term, common ratio equal second term by first term, that is alpha by 1, that is equal to alpha. So this geometric series will converge for mod alpha is less than 1. So sigma n equal 0 to infinity alpha whole power n equal to 1 by 1 minus alpha for mod alpha is less than 1. So here it is z power alpha value z power minus 1. So x of z equal to 1 by 1 minus z power minus 1. So mod z power minus 1 is less than 1. So it is z by z minus 1 and z is greater than 1. Okay, so that means we get plane ROC is beyond the unity circle, beyond the radius 1. So it is represented or it can be drawn like this. Above 1, we have the ROC. Okay, then next problem is x of n equal to a power n into u of n. So x of z equal to sigma n equal minus infinity infinity x of n into z power minus n. So a power n into u power u of n. U of n is varying from 0 to infinity. So n equal to 0 to infinity a power n into z power minus n. So a into z power minus 1 whole power n. The same manner we can draw the ROC also. Okay, and then next problem is find the z transform and switch ROC for the DT sequence. So x of n equal to minus a power n into u of minus n minus 1, right? So a power minus a power n into u of minus n minus 1. So it is a u of minus n minus u of minus n is nothing but it is varying from minus infinity to 0. The u of minus n minus 1 is varying from minus infinity to minus 1, right? So it is a integral n sigma n equal minus infinity to minus 1 minus a power n into u of minus n minus 1 value 1 into minus n. So it is equal to n is minus infinity to minus 1 minus of a into z power minus 1 whole power n. Let p equal to minus n or minus p equal to n. So therefore x of z equal to sigma minus p equal to minus infinity to minus p equal to minus 1 minus of a into z power minus 1 whole power minus p. So p is varying from infinity to 1 minus of a into a power minus 1 into z whole power p, right? Right. So by adding 1 and subtracting 1 for this expression, so it will become sigma p equal to infinity to 1 minus of a power minus 1 into z whole power p minus 1 plus 1, or we can write this as minus of 1 plus sigma p equal to infinity to 1 a power minus 1 into z whole power p plus 1. We can write this as minus of a power minus 1 into z whole power 0 plus sigma p equal to infinity to 1 a power minus 1 into z whole power p plus 1. So it is equal to minus of integral p equal to 0 to infinity a power minus 1 into z whole power p plus 1, or it is 1 minus sigma p equal to 0 to infinity a power minus 1 into z whole power p. Okay. First of all, we will solve sigma p equal to 0 to infinity a power minus 1 into z whole power p, that is 1 by 1 minus a power minus 1 into z with a power minus 1 into z is less than 1. Okay. So its solution is z by z minus a with mod z is less than a. Okay, mod z is less than a. So ROs will be drawn like this. If a is less than 1, then and if a is greater than 1, then it is ROs. Then find the jet transforms which ROs for the DT sequence x of n equal to 0.6 whole power n into u of n and 0.4 whole power n into u of n. So this is term u and this is term b, right? So this is the sigma n equal to the transform of this one is sigma n equal minus infinity into 0.6 whole power n into u of n plus 0.4 whole power n into u of n into z power minus n, but it is given as u of n, so here the limits are changing from 0 to infinity. So sigma n equal to 0 to infinity 0.6 whole power n into z power minus n plus sigma n equal to 0 to infinity 0.4 whole power n into z power minus n. So 0.6 into z power minus 1 whole power n. This is 0.4 into z power minus 1 whole power n. So it is 1 by 1 minus 0.6 z power minus 1 plus 1 by 1 minus 0.4 z power minus 1. Here 0.6 in z power minus 1 mod is less than 1. Mod 0.4 in z power minus 1 is also less than 1. Right? Z is greater than 0.6 and z is greater than 0.4. So x of z is z into 2z minus 1 by z minus 0.6 into z minus 0.4. Okay, it is greater than 0.6 and it is greater than 0.4. R versus are formed like that. Okay, then find the jet transform of the sequence first with x of n equal to e power minus a n t into u of n. Here a is real and the second one is e power minus a n t into u of n, where a is imaginary and these are the two bits. Okay, so x of z equal to z transform of x of n, that is equal to sigma n is minus infinity infinity x of n into z power minus n. Okay, it is e power minus a n t into u of n into z power minus n. So here the limits are changing from 0 to infinity e power minus a n t into z power minus n. E power minus a t z power minus 1 into whole power n. So this is the solution. Z by Z minus E power minus AT, but not Z power minus 1 is less than E power minus AT. If A is real. Then second bit, if A is imaginary, then the solution mod E power minus AT into Z power minus 1 must be less than 1. That is equation number 1. If A is imaginary, then E power minus AT value will become 1. So equation 1 becomes mod Z power minus 1 will be less than 1 or Z is greater than 1. So therefore solution x of Z is equal to Z by Z minus E power minus AT per mod Z is greater than 1. Here both Z transforms are same, but ROCs are different. Okay, right. So this concluding today's class. The next class we'll see the next problems. Problem for finding the Z transform of sin and omega t onwards. We'll see in the next class. Okay, thank you.